On our journey making particles, we have covered a lot of like theory last time, so let's put some of that into practice. Today we're gonna be spawning in our first particles. As a little bit of a recap, we have like a system setup here and a burst effect setup. We're gonna get rid of that. That was just to show you the structure of how everything works. But we also have this empty emitter one, which is just an empty emitter. I put in a mesh renderer there. Let's stick with the normal sprite renderer because that's the default that we have. And we're gonna go through step by step and spawn in a particle and do some basic stuff with it so that you can really start to appreciate how these modules work. So again, last time we went over what these categories mean. So we have like this emitter summary, but for the most part we have emitter spawn, emitter update, particle spawn, and particle update. So in emitter spawn, we effectively don't really do anything for the moment. We can ignore that. Emitter update is where we put in our spawning stuff. So if we just click on that plus and we try to type in spawn, we see we have a couple of different options. We can spawn burst instantaneous, so that will allow us to spawn a certain amount of particles all at the same time. We can say spawn per unit. We're going to ignore that one for now because it's a little bit niche. But for instance, if you want to spawn a particle like every 100 units that a system moves, that is something you can use. And if you generally you would do that for ribbon particles, right? Because ribbon particles connect through like every particle that they spawn. We'll make a video specifically about ribbon particles. Don't worry about that. Spawn per unit will be useful for that. Maybe in that video I will cover it. But for the most part, you don't use this too often. And then we've got spawn rate, which is exactly what it sounds like. It just spawns the amount of particles that you give it per second. So let's show off both of them. We have the spawn burst instantaneous. And if we set the spawn count to like 500, it'll spawn 500 particles here in the middle, and it won't really do anything else at the moment yet, because we don't have anything telling it to do something. It's as easy as that. So let's tell it to do something. And that is on particle spawn, we can tell it to do a thing. For instance, we can add velocity. And we have to, when we add velocity, and this is the nice thing about Niagara, some modules have dependencies. So when we add velocity to a particle, we also need to include solve forces and velocity, so that the particle system can calculate where everything needs to move and stuff. It just gives you these buttons here, which you can just click to fix any dependency issues that you might have. So we just fix issue and boom. Now we have a particle that moves upward when it spawns in. But it spawns all of them in at the same time, and they all move exactly in the same direction. So it just seems like we still only have one. So maybe instead of all spawning them in the same place, what we want to do is we want to spawn in a shape location. This is another one that you're going to be using a lot. You can also spawn things on the surface, for instance, of a static mesh or even a skeletal mesh. I have a separate video about this, which is really, really cool. But a lot of the time you're going to spawn things in a shape location. And what that will do is, in this case, it'll by default say it spawns them in a sphere, and that sphere radius will be 100. So it'll kind of just calculate a sphere with a radius of 100, and every time it spawns a particle on it, it will spawn it at a random place on the surface of that sphere. At least that is the default behavior. You can spawn them randomly. You can spawn them what is called direct, which will give you the U and V positional data. So you can specifically say where on the sphere you want it to spawn. And if you spawn them uniform, it kind of does what it sounds like it will do, right? It spawns all of the particles from spawn burst instantaneous, evenly spread across the sphere. Of course, we have multiple different types of shapes that we have. We have a cylinder or a box / plane, a torus, which is a donut shape, which is quite nice for a lot of things as well. Then we've got a ring, which is a donut shape, but in 2D, so it doesn't have like actual height, it's just a ring. And then we've got the cone as well, which is just a cone shape. There we have a spherical cone or a spherical wedge. That's all fine. Let's stick with the sphere. I do want to show you some differences though, because this is all with spawn burst instantaneous, which is quite nice. But what if we change this over to spawn rate instead? And we spawn, for instance, 15 particles per second. We still, in our shape location, have this thing set to uniform. But because it's only spawning one particle at a time, it's uniformly spawning that in the middle of the shape. So that doesn't actually work all that well with uniform. But unlike with spawn burst instantaneous, with direct was a little bit useless, because it was just, you needed to pass in the exact coordinates of where you want to spawn it, and it can be a little bit bothersome. If you use spawn rate, it will actually kind of spawn them across the surface of your sphere in order, which will create this very like neat circular effect, which is kind of nice. Specifically as well, if you do this on a ring instead, and you set this again to direct, it really starts creating this little spring shape, which is quite nice to be able to do. There's a lot of things that you can play around with here. You can have like the disk coverage in this case for the ring, so that's also like, does it spawn things on the surface or only on the outside? And then we have some distribution stuff. We're not going to really bother too much with that. For now, let's go back to the sphere, and let's do this just randomly. So we now have these spawning on a sphere and going into the sky at a velocity of 50 units upward. So we can also give them 50 units in the Y, and now they all move in that direction. And we can give them 50 units in the X, and now they move in all three directions in the positive, right? So this is just how that works. And the thing is, there's a lot to do here. I want to talk a little bit more about like more advanced setups for like creating values for these things in its own separate video. For now, suffice it to say that with this little arrow thing here, we can upgrade this velocity from just being a vector 3 value to being something that is a little bit more based on calculation. And this is also where we can add in randomness. Because remember, we're now in particle spawn, so every single particle is going to run whatever code we put in here. So in this case, for its velocity, for itself. So if we say we have a random vector and we set that vector scale to 50, now every single particle is going to be set off at its own velocity in its own direction. And we suddenly have like this thing going on, which is quite fun. And in much the same way, we can give this like a color as well. And the color, very much the same thing. We can get a random range linear color, which will give us a minimum color, let's say blue, and a maximum color, let's say red. And now everything is going to be colored between that red and that blue. And because this is in particle spawn, once again, this will randomly generate something for each individual particle for its data. But what if we don't want to just set one color and be done with it? What if we want to do something a little bit more dynamic? So let's get rid of the color in the particle spawn, and let's actually move to the particle update. Because what we can do is we can actually set, instead of the color directly, we can scale the color. And if we scale a value, that means that we're going to be able to change this to RGB and alpha together. This will make a vector 4, and we can get a vector 4 from curve. So this will create a gradient that will fade out from, in this case, white to white and from opaque to transparent. I'm going to set this opacity to a value of 1, just so that you can see it a little bit better. And if we set this color to like purple or pink, you can see as they near the end of their lifetime, they slowly turn pink. And that is because our curve index, this value that we have right here, is set to the normalized age. So that means that when we are at the left-hand side here, this is a normalized age of 0. So that's the beginning of their lifetime. All the way to the right here, we have the normalized age of 1, which is the end of their lifetime. That is what the normalized bit in normalized age means. Their age, how far along they are in their lifetime, shown as a value between 0 and 1. we can put anything we want in here. We can do a not normalized age. So just their age in, I think it is at that point, measured in milliseconds or maybe in seconds. And that way we can say during the first second of your lifetime, you do this. And after that, you just stick at the value of 1. You can do a lot of other interesting stuff with it. You can say put in the velocity here instead. So when something is standing still, it'll have a color value of 0. And when it's moving at its whatever its max speed is, it will have a color of pink, and so on and so forth. So you can do a lot of very fun stuff. Now, this is called a curve for colors. It's a gradient, so that's maybe a little bit confusing. So let's do something a little bit different. And that is, instead of just scaling the color, which again is a little weird because it's called a curve, let's scale the sprite size. So we can scale the sprite size, or we can scale the mesh size. That depends on whether or not you're using a sprite renderer or a mesh renderer, or God forbid, within the same emitter, both. We are using a sprite, of course, so we're going to scale sprite size. And that gets you a more normal looking curve, right? So here we have on the y-axis, we have the scale of our sprite. And then on the x-axis, we have the normalized age. So this is exactly the wrong way around. They start very small and they end very big now. We've got a couple of different presets here that we can very easily use. So let's, for instance, use this one as a preset. And you can see that right now they seem to have disappeared. And that is because they are being set to an incredibly small number. So we have this uniform curve scale. And that just takes this curve, which usually you make these curves of between values of 0 and 1, just have them be workable. But then if you want them to actually apply bigger values, you increase the curve's scale. So if we set that to 50, it will be much bigger. What is also important to note is that in order for this to work, we actually need to go into the initialize particle thing here. And an empty emitter will come with an initialized particle. And this is where we set up a couple of important things. So we should probably take a look into this anyway. Because in here we have the lifetime mode, which is direct set for the most part, that's good. And then the lifetime, which is how long the particle will live, the color mode, the position, all that kind of stuff. The thing that we care about right now is our sprite size, because that is set to unset. If we're trying to set that then within our modules later down the line, like with our scale sprite size, it's not going to do anything. So what we need to do is we need to set sprite mode to whatever we want it to be. So we have got uniform, random uniform, non-uniform, and random non-uniform. So if we set it to uniform, we just get a float value for its size. So if we set this back to 1, it's very small, but it's getting scaled up by a factor of like 50 in our sprite size. So let's set this to a factor of 5 instead and keep this at the default value of 10, which will make the particles roughly the same size that they were just a moment ago. And you can already see that this feels like there's something happening, right? This feels quite organic and quite nice to look at. Now, we also have got a random uniform, and this will give each individual particle, when it is initialized, a random size between a minimum and a maximum. So we can give like the minimum for 2, and then the maximum can be like 25, which means that we have very big differences in the sizes of these particles. And then when this sprite size gets scaled, it gets scaled based on what the initial size that was applied to it is. So this is just a curve that says what percentage of its actual size it is. Its actual size is set in the initialized particle, and then the scale sprite size just says, okay, you are now at 0% of that size. You are now at like 90 something percent of that sprite size. And that toward the end here, you are once again at 0% of that size. And we can change the scale of that curve again with this value down here. And that's pretty much how it works for everything, right? So we can set its initial color, for instance, as well. So its color mode is unset right now. You can make a color with the module that we just showed you. But you can also just set it directly in here. And that just gives you a color to directly set. And of course, you can also do a random in range or a random use saturation value. You can do a lot of like interesting, fun stuff with this. Now, one thing that you will note is that I changed the color here to, let's do random in range, to like blue, and maybe, like, let's do yellow, something like that, right? And they still fade out into a pinkish color, and the yellow ones fade out into an orangish color, which is what, like, we never said orange anywhere. What the hell is happening there? That is because this scale color applies a tint to the base color. So if the base color is just white, this is just going to apply the color directly. But if the base color, for instance here, indeed is yellow, if this magenta gets applied to that yellow, that makes an orangish color. And of course we have, in the end, our sprite renderer, which has a bunch of other settings as well, which we'll eventually surely get into a little bit more. Feel free to explore that. I'm going to, just for laughs really, I'm going to add in a mesh renderer as well to show you. We can add in more than one mesh even if we want to, at which point I believe every single particle will take a random mesh out of this, or it will take all of them, or you can actually set up what you want to happen. So let's give it the like default cube here, like the static mesh shape cube. And it will spawn all of those in, which is like a very, very weird feeling thing. And you will notice that they don't actually scale up and down because we are setting the sprite size by curve, but we're not doing any such thing about the mesh size. So if we want to scale the mesh in the same way, what we need to do is we need to scale the mesh size, which makes it disappear. Because, of course, in our initialized particle, we need to set our mesh scale mode to, in this case, let's just go for like uniform and set it to 1. And now it will scale them to 1, 1, 1, because we don't have a curve set up yet. Of course, we can set up a like vector from curve, and now they will shrink over their lifetime. Now, one last thing that I want to do, just to make this look a little bit more interesting, we actually have a facing mode option here. Specifically for meshes, this is interesting, because by default, it will just kind of spawn them in world aligned, and that's kind of boring. So we've got, we can make them always face toward the camera, which specifically for these cubes kind of makes them just into squares, right? So I probably don't want to do that. But that is something that you can do. You can make them align to the camera plane. So you will note the difference being is if you look at the particles that move away, they still rotate themselves in 3 directions toward the exact position of the camera. If we go into the camera plane, they just rotate themselves in the one direction to look into the general direction of the camera, but not at its exact position. By far the most fun and useful though one is align to velocity. So they will now rotate themselves toward the velocity that they're traveling in, which makes for a much more interesting looking system. Except of course there's not a system, this is an emitter. We need to put it inside of the system to actually do something with it. We've gone over that in the last video. For now though, I think that we have spawned in our first particle. We can add our sprite renderer back into this as well. It'll look a little bit weird to have both of them. Every single particle now has a mesh and a sprite, which is fun, I guess. And we'll leave off there for right now. I think there's a little bit of experimentation that you can do with this now. This was a lot of just throwing things at you to make sure that you have a basic understanding of like what is possible, like what options exist, and how to put in these separate modules and work with them and how they interact with each other. And where to look if something isn't working, that kind of thing. I think you have a pretty good base now to start experimenting. Next time, we're going to go in a little bit deeper again, and we're going to do some more fun stuff. So I'll see you back then. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sir J. Thomas,